Okay, so let's try the electron configuration for, is iron on your sheet?
Yeah, iron.
Okay, I don't want to do iron then, okay? Are cobalt or nickel on your sheet?
No.
Okay, so let's do nickel. Let's do nickel, okay?
Let's do iron.
Okay, so remember we're going to go with lower energy first. First, guys, look on the periodic table. How many electrons total do we need for the nickel atom?
28.
28. And you know that's atomic number, right, which tells us the number of protons, but if we're talking about a neutral atom, then the electrons are the same. So we have 28. Where should the first electrons go to give us the lowest energy for this atom? The 1s. Okay? And so like here, remember we're going to do the 1s first. And how many electrons fit in there? 2. Okay? So here on the energy diagram, we're down here. Okay, so does this show up on the video? The one, this below? Yeah. Okay. So the 1s is the lowest in energy. Okay? And the periodic table, I just want you to see that it's a map in the order of energy. So we have the 1s first. Okay? All right. So after that, remember this has an atomic number of 1, an atomic number of 2. Do we go over here? There's nothing there, right? Okay, so we have to go to element 3 and element 4. So element 3 is here. It's on the second row. And so what's our next spot? 2s. And we know that s's can hold a maximum of 2. All right? So right now we've got 4 electrons in. On the periodic table, if you're following along, you're actually at beryllium, right? Okay, so 3, 4. Now go to 5. Where are we at? We go from beryllium over to boron. So 3, 4, now we're at 5. I think I might have misspoke before, so we're in element 5. Where is that? What row? 2. What section?
P.
Perfect. Okay. And how many total electrons can fit there? 6. So now we're up to 10 electrons. So after the 2p6, you can use your map. We're right here. Okay, you can use your map and we're going to go here. What row are you on?
3.
We're on the 3rd energy level, the 3rd row, and what section are you in? S. And how many electrons fit? 2. Okay, so like if you're looking at the chart, you're actually now on magnesium. We're up to 12 electrons. After 12 comes 13. Case, can you flip it over there so you can just see that? Okay, so after 12, we just follow the map. Now we're on 13. What row are we still on? 3. What section are we in? P. And how many electrons can fit? 6. Okay? So our next thing will be 3p6. Okay? So now we're right here. And if you look, and let's just keep going for just a couple minutes. Okay? So now we're at 3p6, so we're actually kind of right here at argon. Go to the next number. After 18 comes 19. Now, follow the chart. What row are we on? 4. What section are we in? S. And so that's what we have to write first. Okay? 4s and 2 electrons will fit there. So now we're at 20 electrons. But we have to get to 28. So now we have to go in here. Okay? What section is this? D. Now, this is where there's an overlap. Remember before when we said the first energy level has just an S, the second has an S and a P, the third has an SP and a D? This is the first time we've gotten to a D. So what D is it? It's the 3D. Okay? And if you count over to nickel, you're over 1, 2, 3, 4, 5, 6, 7, 8 blocks. 3D8. Okay? And so guys, if we were to look here, what happens? You have 1s, 2s, 2p. This is the energy diagram. 3s, 3p, 3d. And then what happens is the 4s, 4p, 4d, 4f, they go up in energy, but notice there is an overlap. The 4s, I tried to draw it to where it was here. The 4s, it turns out, has an energy between 3p and 3d. And so that's why we fill it first, okay? But what's very interesting is this. If you look at the valence shell, still the valence shell is where the energy level is the highest. Where's the highest energy level here? The fourth. And so these are the valence electrons, okay? So if you were to write the Lewis dot formula for nickel, it would be, yeah, it would look like that. You'd have 2 electrons, okay? In fact, most of the transition metals are going to have 2 valence electrons. And if you look at possible charges for transition metals, it almost always includes a charge of +2. And that's not a coincidence. Okay? Does everybody get this?
Yes.
Do I need to go over the orbital diagram that goes along with this one, or is it pretty self-explanatory? You want me to do it real quick? Okay, so...
No, I was saying we're good. We're good.
No, I know, but someone else was saying that. So here, we've got
I thought she was looking.
the 1s, we've got the 2s, we've got the 2p, we've got the 3s, we've got the 3p, we've got the 4s, and then we have the 3d, which is going to have 1, 2, 3, 4, 5 orbitals in it. So here, we'll have up and down. Here's 1, 2. Here's 1, 2. Here's the 6. 1, 2, 3, 4, 5, 6. The 2 that go in here are up and down. The 6 here, 1, 2, 3, 4, 5, 6. The 2 in the S, up and down. And then the D, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Do you guys see that? And again, the reason why we fan them out first is because that minimizes electron repulsion so that that's a lower overall energy for the atom. Does that make sense? Okay, great. Thanks, Case.